You know what is meant by fractional part of x? You must have tried solving some equations also. Equations involving fractional part function, greatest integer function, modulus function, a mixture of all the three. All these things you must have tried. Now we take up our main job, the job of finding domain range. We are required to obtain domain range for these functions now. First, y equal to square root of fractional part x. Is the function defined for every value of x? For every x, can you find fractional part? Yes. What value you get? A number between 0 and 1, including 0, excluding 1. Apply square roots. Is it possible to apply square root for any number obtained as fractional part x? Yes, no problem. Domain is the entire set of real numbers. What about range? Just now you noticed this argument of the radical function, fractional part x, takes values between 0 and 1, including 0, excluding 1. When you apply square root, what happens? Again you get a number between 0 and 1, including 0, excluding 1. Range is interval 0 to 1, closed at 0, open at 1. Second function. One second. Suppose you have a minus 1 here. Will there be any change in the domain of the function? Yes. Now the function will not be defined for every value of x. For what value of x will it be defined? For no value. Because for every admissible value of fractional part x, this difference will be a negative quantity. Therefore, the function is undefined everywhere. Domain is empty, so range also will be empty. Will have a non-zero domain. What will be the domain of the function? The expression is meaningful as long as fractional part x minus half is positive. Fractional part x minus half is need not be positive, non-negative. Fractional part x is greater than or equal to half. For which numbers do you get fractional part greater than or equal to half? 0 and no. Half to open interval 1 is one interval, one collection of points at which the expression is meaningful. Likewise, there are many more points. When n is an integer, arbitrary integer. Now the fractional part will be half. Am I right? No. Fractional part will be half. Fractional part minus half will be 0. Square root will be obtainable, will be well defined as a real number. Starting from here, up to what point we can go? Next, integer. What is that integer? N plus 1. But for this number, fractional part will be 0. Difference turns out to be a negative number. Root will not be meaningful. So this to be excluded, to be included. Take the union, infinite union, as n ranges over the set of all integers. What about range? What values are taken by fractional part x for numbers like this? It will be fractional part will be a number from half to 1, a number between half and 1. subtract half from it. Difference will be a number between 0 to half. Apply square root. 0 to 1 by root 2. Range will be an interval with left hand point 0, right hand point 1 by root 2. Width is 0 attainable? Yes. 1 by root 2? Not. Agreeable, I think. Is the function meaningful? Is the function formula applicable at every point, at every real number x? Yes. Domain is the set of all real numbers and range is the set of numbers between 0 and root 2. Agree? 0 and root 2 with 0 included, root 2 excluded. Am I right? Yes. What is the domain? Domain is the set of all real numbers x such that this is greater than or equal to 0. That means fractional part x must be greater than or equal to half. What we noticed one example earlier. Okay? For any real number x, fractional part x is a number between 0 and 1. So what can you say about this difference? Always greater than or equal to 0. Square root is always defined. Domain is the set of all real numbers and range is, this takes values between 0 and 1. Therefore, this takes values between 0 and 1. Which point included, which point excluded? 1 included, 0 excluded. Square root of that will be again a number between 0 and 1 with 0 included or 1 included. Which one included? 1 included, 0 excluded. Right. Domain is set of all real numbers. Range, numbers between 1 and 2. Numbers between 1 and 2. Which endpoint included? 2. 2 included. 1 excluded. Good. To have the formula applicable, we need 2 minus 3 into fractional part x to be greater than or equal to 0. 3 into fractional part must be less than or equal to 2. Fractional part x must be less than or equal to 2 by 3. All numbers having fractional part between 0 and 2 by 3 will form the domain of the function. What are the numbers having fractional parts between 0 and 2 by 3? Numbers between an integer n and n plus 2 by 3. Is n included in the interval? Can you have fractional part equal to 0? Yes. Can we have fractional part 2 by 3? We can. If this is 2 by 3, this becomes 2 minus 3 into 2 by 3, 0. Square root finding, no problem. We are not getting that 0 in the denominator. Okay. Infinite union as n ranges over the set of all integers. What about the range? This is a number between 0 and 1. This is a number between 2 and 3. Sorry, 0 and 3. Am I right? The number is subtracted from 2. Difference will be a number between only non-negative values you need retain, negative values you may reject. What are the values? Admissible values. This is between 0 and 3. Admissible values will be between 0 and 2. Are both endpoints included? Yes. So range will be closed interval 0 to root 2 with both endpoints included. Agreed, I think. Next. When is the function formula applicable? What are the points belonging to the domain of the function? A requirement. The expression under the radical sign must be greater than or equal to 0. The set of all x such that this expression greater than or equal to 0 forms domain for the function. Okay. One approach, consider the graph of y square plus 2y minus 3. From that graph, identify that portion which corresponds to this, then determine when is it positive, when is it 0, when can it be negative. An alternate approach may be method of completing squares. Expansion gives me this term. As third term I will be getting plus 1, my requirement minus 3, so I must subtract 4. To have this, a square to be greater than or equal to 4, the value of the expression within parenthesis must be either greater than or equal to 2 or less than or equal to minus 2. To have this greater than or equal to 2, this quantity must be greater than or equal to 1. Does there exist any number with fractional part greater than or equal to 1? No. For no x, you get this thing greater than or equal to 2. Other possibility, this must be less than or equal to minus 2. For that, this must be less than or equal to minus 3. When? Yes? Okay. So, range also is fine. Okay? Clear, I think. Yes. Even otherwise, the highest value this can take is 1. So, the highest value this expression can take is 3. Is it not? And that 3 is not attainable. Suppose instead of having this, you have the same expression with a different sign here. What happens? Expansion covers this. As third term, we will be getting 1. Remaining portion 2 shifted to the other side, this much. Is this always greater than or equal to minus 2? Being a perfect square, is always greater than or equal 0, must be greater than or equal to that number also. Okay. Yes. Yes. Always, perfect square. A perfect square can never be negative. Is always greater than or equal to 0. Okay? Yes? Or yes? Minus 1 by 2. Again a negative number. Sorry, I wanted a small positive number here. What to do? Minus, no, plus half. Okay. Oh, minus half only. I'm sorry. Minus. Now what about this number? Plus half? Sarita? Okay, this gives me plus 1. So there is an extra half. Fine. Yes. ಸರಿ ಹಾಂ ಓಕೆ ಹಾಂ 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 ಸರಿ ಅಲ್ಲ ಕರೆಕ್ಟ್ ಉಂಟಲ್ಲ ಓಕೆ ವೆನ್ ಈಸ್ ದಿಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ A perfect square is greater than or equal to a positive number when the number which is squared here, either it is greater than or equal to 1 by root 2 or less than or equal to minus 1 by root 2. Can this be greater than or equal to 1 by root 2? This is greater than or equal to 1 by root 2 means this is greater than or equal to 1 by root 2 minus 1. When does this happen? What is the sign of 1 by root 2 minus 1? What kind of number is 1 by root 2 minus 1? A positive number or negative number or 0? Negative number. Will this be always greater than or equal to negative number? Finished. The domain is the entire set of real numbers. Okay. Now what about range? In this example, what will be the range? What values are attained by this? What values are attained by this? 1, 2. My function formula is this one, is it not? With constant term changed. Okay, this is my function. So I need find what values are attained by this expression. This expression is written applying the method of completing squares as fractional part x plus 1 whole square minus half. This takes values between 0 and 1. This takes values between 1 and 2. The square takes values between 1 and 4. Minus half will be a number between half and 3 by 2. Square root will be a number between 1 by root 2 and root of 3 by 2. What about the end points? They are covered or not? Can this be equal to 0? Oh, sorry. What is that my requirement? 1 by root 2. Can this be equal to 1 by root 2? To get this 1 by root 2, I need this to be 1. Can this be equal to 1? To get this 1, this must be 0. Can this be equal to 0? Yes. Left hand point included. The other end point is root of 3 by 2. To get this as root of 3 by 2, this must be 3 by 2. Or this must be 2. From where I am getting 2? This lies between 0 and 1, this lies between 1 and 2, square lies between 1 and 4, minus half lies between 1 and not 3 by 2, 7 by 2, square root lies between 1 and root of 7 by 2. Huh? 1 second. 1 and 4, yes, 1 minus half and 7 by 2. So 1 by root 2 and 7 by 2, these are the endpoints of the interval. To have the value of the function equal to 1 by root 2, this must be half. To have this equal to half, this must be 1. To have this equal to 1, this must be 1. For that, this must be 0, is acceptable. Therefore, left end point included. To have the value of the function equal to this much, this must be 7 by 2. That means this must be 4. That means this must be 2. That means this must be 1, not reachable. Fractional part of any number is always less than 1, strictly less than 1. So range becomes this half open closed interval, closed at the left hand point, open at the right hand point. Fine. Next function, reciprocal of square root of fractional part x. The only catch where the function may remain undefined is the point where denominator equal to 0. Denominator equal to 0 when fractional part equal to 0. Fractional part is 0 when x is a integer. So only points where function remains undefined are integer points. Domain will be set of all real numbers with integers removed. Okay. What about range? Integer points have been removed. Now the fractional part cannot be equal to 0, but can take any other value. Remaining admissible values for fractional part are numbers between 0 and 1, open interval 0 and 1. This is a number between 0 and 1. Square root also will be a number between 0 and 1. Apply reciprocals. What is reciprocal of 0? Your x is a number between 0 and 1, won't go to the other side of 0, infinity, plus infinity. Agree? Reciprocal of 1 is 1. Form the interval with these as endpoints, 1 to infinity. Is 1 reachable? Fractional part can never be equal to 1. Is it not? Yes. What will be the domain now? All real numbers. No exclusions. What will be the range now? This takes values between 0 and 1. This takes values between 1 and 2. Root takes values between 1 and root 2. Reciprocal. For numbers between 1 and root 2. Which endpoint is not reachable? The one obtained by taking this equal to 1. For this equal to 1, which endpoint you are getting? Left or right? Left one. Right endpoint is reachable. It corresponds to the value fractional part equal to 0. Domain. Null set. The only case where the function formula may remain non-applicable is the case when the denominator vanishes. Is there any possibility of getting this expression equal to 0? There are two ways for checking that. One, by drawing graph for y square plus y plus 1 and identifying the portion corresponding to this function. Another method, completing squares. Suppose you apply the method of completing squares. When squared, this term will be covered, this term will be covered, this will not be fully covered, only partially covered. The part remaining uncovered is 3 by 4. This is always greater than or equal to 0. This will be always greater than or equal to 3 by 4. Will the denominator always remain non-negative? Will it always remain positive? Yes. Domain is set of all real numbers. What about range? This lies between 0 and 1. This lies between half and 3 by 2. Square lies between 1 by 4 and 9 by 4. Plus 3 by 4 lies between 1 and 3. Square root lies between 1 and root 3. What about negative values? Square root may also lie between minus root 3 and minus 1, is it not? Huh? Yes or no? I don't know. When you find square root of a number, won't you get two acceptable values? But here, you won't consider the negative root. Why? You are not obtaining the root as a solution of equation x square equal to k. If you are solving an equation x square equal to k, you will have to consider both admissible values of root k, plus root k or minus root k. Now you are not doing that. You are already having the radical sign, the square root of a number with positive sign. No point in bringing in the negative square root from outside. So what limits did we get? This total quantity lies between 1 and 3. Is it? The square root lies between 1 and root 3. Reciprocal lies between 1 by root 3 and 1. Are both endpoints reachable? This cannot become 1. Among the admissible values of this, the point 0 is reachable, 1 is not reachable. So, for this sum, half is reachable, the other endpoint 3 by 2 is not reachable. 1 by 4 is reachable, 9 by 4 is not reachable. 1 is reachable, 3 is not reachable. Agreed? What will happen to the expression now? 1 has been removed. Subtract 1. Okay. This lies between 0 and 3 by 2. Square lies between, this lies between half and 3 by 2. Square lies between 1 by 4 and 9 by 4. Minus 1 by 4 lies between 0 and 2. The square root lies between 0 and root 2. There are points where denominator vanishes. I am just making the statement. I have not checked it. Does the denominator ever become 0? To have the value of the denominator 0, this must be equal to number squared must be equal to half. That means this must be equal to 0. Can this be 0? Yes. There are points where denominator becomes 0. So therefore the domain will not be the whole set of real numbers. Some points will have to be kept outside. What are the points to be removed from the set of real numbers? Integers. The points where this is 0. Okay. We are considering only the remaining points. Then this will not be 0. This will be a number strictly between 0 and 1. So this will be strictly between half and 3 by 2. Strictly between 1 by 4 and 9 by 4. Strictly between 0 and 2. Square root is strictly between 0 and root 2. Reciprocal will be strictly between reciprocal of 0 and reciprocal of root 2, 1 by root is the range. As before, this lies between 1 by 4 and 9 by 4. Minus 1 and 1. Agree? 9 by 4, minus 1 and 1. Minus 1 and 1. So there are certain points where the expression under the radical sign becomes negative. Domain will not be the entire set of reals. We have to find out when is it positive, when it is non-positive. Okay. To have this quantity strictly greater than 0, my requirement is strictly greater than 0. This must be greater than or equal to 5 by 4. The number within brackets must be greater than or equal, not equal to, strictly greater than root 5 by 2. There is another possibility. To get the square of a number greater than 5 by 4, you need not have the number greater than root 5 by 2. It may also be less than minus root 5 by 2. But that possibility I need not consider here. This number will never be less than minus root 5 by 2. Do you agree? This is less than root 5 by 2 minus root 5 by 2 means this is less than root 5 minus 1 divided by 2. Negative of root 5 by 2 minus 1. It is a number much smaller than 0. This cannot be negative number. So that possibility won't arise. Agree? So only possibility is to have this greater than 0. This must be greater than root 5 by 2. This is greater than root 5 by 2 means this is greater than root 5 minus 1 divided by 2. Okay. When is fractional part x greater than root 5 minus 1 divided by 2? What is a approximate value for this? 2 point something. Minus 1, 1 point something. Divided by 2. Is it a number strictly below 1? Yes. So there will be some x for which this condition is satisfied. We need retain those points. Which are those points? Least value fractional part x can have is this. Mention one number having fractional part equal to this. Next, I will find a general expression for that. Any one number having fractional part equal to this. Itself, what is fractional part of this number? You notice, just now notice, it is just greater than half. 1 point something divided by 2, just greater than half. What is its fractional part? Itself is one number having fractional part equal to that quantity. What are the other numbers having the same fraction as the fractional part? They are numbers of the form where n is an integer. Our intervals start from here, and we can start from here and go up to what level? Till the fractional part gets closer to 1. When does it become 1? It will never reach 1. When will it get closer to 1? Next integer. Okay. We need that expression to be strictly greater than 0. This value is never reachable by fractional part. Take a union of all such intervals as n ranges over the set of integers. What you have obtained is the domain of the function. Okay? Is it clear? This is greater than or equal to, this quantity is greater than, not equal to, greater than 5 by 4. This is greater than root 5 by 2. This is greater than root 5 minus 1 by 2 that I have recorded here. I am just identifying those numbers with the fractional part between root 5 minus 1 by 2 and 1. No number has fractional part 1, so open interval. We need strict inequality here, so open on this side also. Take a union of all such intervals, infinite union, you are getting the total, entire, the collection of all numbers having the formula applicable, the domain of the function. Agreed, I think. No complication involved. Range. Range is the set of all values attained by this function. Our fractional part is always greater than root 5 minus 1 by 2. This is greater than root 5 minus 1 by 2. So this is always greater than root 5 by 2. This is greater than 5 by 4. 5 by 4, a number greater than 5 by 4 minus 5 by 4 is greater than 0. Reciprocal of 0, infinity. Our range will be consisting of numbers less than infinity. What about lower bound? Upper bound is infinity. What about lower bound? What is in order to get the lower bound for reciprocal of a function, I must consider the maximum value attained by this. At the maximum value of the denominator, you get the least value of the reciprocal. At the least value of the denominator, you get the highest value of the reciprocal. You have already got the highest value as infinity. Now what is the least value? It corresponds to the highest value of denominator. When is denominator maximum? When this is maximum. Agree? You have no control over this. This you will have to subtract from whatever you get from here. So you have to make this maximum. When is this maximum? When this is maximum. What is the maximum? 1. Not attainable. Remember it. Maximum is 1. 1 plus half is 3 by 2. Square is 9 by 4. Minus 5 by 4 is 1. Square root is 1. Reciprocal is 1. Is the range. If you want to cross check, take a sample value. Say x is equal to 0.9. Or let me consider a fraction. Better, easier to make calculations. Say yes. Half may not be enough, I think. Our number starts with a number greater than 3 by 4. Okay. 3 by 4 plus 1 by 2. 3 by 4 plus 2 by 4. Square. Minus 5 by 4. What happened? Huh? Yes. 5 by 16. I am taking this 3 by 4. 3 by 4 plus 2 by 4, 5 by 4. Square is 25 by 16. 25 by 16 minus 20 by 16. 5 by 16. Square root. Root 5 by 4. Reciprocal. 4 by root 5. Is it a number in this interval? 4 by root 5. Which example we covered now? This one. This is over now. Only one example remaining. The trigonometric sine ratio of fractional part x. Is everywhere defined. Yes. And when definition is applied, you are getting a number between 0 and 1, 0 included, 1 excluded. For that you have to apply sign. Can sign be applied to any number between 0 and 1? 0 included, 1 excluded. Yes, you can. Domain is all real numbers. What about range? We just now noted this is a number between 0 and 1. You are applying sign ratio to it. Sign of a number between 0 and 1 can have value between sin 0, 0 and the other endpoint. Is sin 1 equal to 1? It's an unknown number. By 1 I mean here 1 radian. By sin 1 I mean sin of 1 radian. An angle approximately equal to 60 degrees, not equal to, just less than 60 degrees. So sin ratio will be a number slightly smaller than root 3 by 2. The interval will it be closed at 0? Yes, because 0 is reachable. 1 is not reachable, open. This is the range, this is the domain. Any change in your conclusions? No. Same domain, same range. Any differences? No. Same domain, same range. Both are null sets. Both domain and range are null sets. The next special function that will be of interest, some interest for us, is the sine function, or to avoid confusion between your trigonometric sine and this sine function, let me call it signum function. It determines sine of a number, that's all. For any x I define, for every x belonging to R, I define signum x to be 1 if the number is positive, 0 if the number is 0, and minus 1 if x is negative. That's all. This is how we obtain the signum of a number. So signum 1 is 1. Signum pi is 1. Signum of root 2 is 1. Signum of integer part of 5 is 1. Signum of fractional part of minus 2.3 is 1. because fractional part minus 2.3 is 0.7 positive. Signum of integer part minus 2.3 is signum of integer part of 5 is, sorry, fractional part of 5 is 0. Signum of fractional part pi minus 3.1416 is 1. Good. Signum of fractional part of root 2 minus 1.4 is 1. Signum of integer part of root 2 minus 1.4 is 0. Okay. Huh? This one is not the fractional part of pi. Okay, sorry. No, why should I feel sorry? Yes, I am considering the fractional part. Why are you confusing me? I think what I wrote earlier is correct. Pi is just greater than 3.1416. Therefore, the difference will be a positive fraction. The fractional part is itself. Is the difference negative? Is pi less than this? What is an approximate value of pi? 14159, not 16. Okay, then this is negative. Still, fractional part is positive, so signum will be 1. The only thing is whether fractional part is 0 or not. That we have to be careful. Fractional part is never negative. Right. Okay. A few examples on finding domain range of functions involving signums. All very short problems, no discussions may be needed on these. I'll just write down the function. Immediately you have to tell me what is the domain and what is the range. This is the formula defining the function. About domain, I think there is no confusion. What about range? Can this be 0? How to check whether a quadratic can be 0 or not? Find the discriminant. Discriminant is b square. Yes, what should it be in order to have in order that real roots may exist for this quadratic? Discriminant must be greater than or equal to 0. What is the discriminant? 1. How 1? Which formula you are applying? Root 17. Is a number strictly greater than 0? You are sure that there are 2 real roots for the quadratic. Therefore, the quadratic can be 0, will be 0 at 2 points, and signum, one admissible value for signum value of the function is 0. Can this expression be positive also? Yes, sample value, say x equal to 5. Choose a sufficiently big number. You find the expression to be a positive number. Signum can be 1 also. Can the expression be negative also? For which value it will be negative? Sample value, one sample value. Say x equal to minus 1. What is this? 2. Is it not? 2. This is minus 3. 2 minus 3 minus 1. Is it negative? Yes, signum can be minus 1 also. So, range will be set of 3.01 minus 1 and domain is the set of all real numbers. Okay. Now, is there any change in the domain of the function? No. Even now, domain remains to be the set of all real numbers. What about range? Can the function value be 0? No, because discriminant is negative now. Can the function value be 1? Yes. Can the function value be minus 1? I don't know. No. How are you sure? I want a justification. Graph. How does the graph of 2x square plus 3x plus 10 look like? Is a parabola with vertex below. What is the x coordinate for this vertex? Minus b by a, minus 3 by 4. What will be the y coordinate? You need tell me whether the y coordinate may be positive or negative. It's enough if I know the sign of the y coordinate. Are you sure it is positive? That means all points lie strictly above the x-axis. At no point the function value becomes negative. Therefore, there is no possibility of getting function value equal to minus 1. Range is a singleton consisting of single point plus 1. Good. Next, signum of sine ratio of mod tan x. Is the function defined at all points? I am trying to find the domain. No. The function tan x, one of the portion of the formula that we are making use of, is not always defined. This is not defined at a very point. Which are the points at which tan x is undefined? Give me the collection of the points. N pi is not tan defined at pi. Is not tan defined at 0 pi. 2n plus 1 pi by all odd multiples of pi by 2 you mean. Okay. In this, what are the values that you can assign for n? Any integer. Should it be positive only? No. Maybe negative, maybe 0 also. Will be the domain of the function. Excluding tan x, there is no problem with any of the remaining. Notice that. The problem we are facing is only with regard to this portion. Once this is defined, there is no difficulty in finding sign. Theoretically, we can find sign. Once sign has been obtained, we can determine the signum. Therefore, everything else is always defined. The problem is only with this, and this is undefined at these points. This will be the domain of the function. What about range? What values are attained by this? Minus infinity to infinity. What values are attained by this? 0 to infinity. What values are attained by this? This is taking only those values which are greater than or equal to 0. So, what values will be taken up by this? Are negative values taken now, even now? Yes, all values from minus 1 to 1, including minus 1 and plus 1. Therefore, the collection of values this takes will be 3 element set, minus 1, 0, 1. Good. Will there be any change in any of your conclusions now? No. All things remain the same. Both domain and range remain the same. Okay. Now, yes, there will be, which may be difficult to find out. This is undefined at these points. When you apply tan, you will be getting numbers between 0 and infinity. That interval again contains points like pi by 2, 3 pi by 2, so on. Negative points may not be there, but positive odd multiples of pi by 2 are there. For those points, tan cannot be found. So those points also will have to be identified and will have to be kept outside the domain. It requires little more computations. I avoid that. Next example, let me consider signum of fractional part x. Very simple exercise. Domain, all real numbers. Range, immediate. Answer should be immediate. Two element set, 0 and 1. Minus 1 will not be there because fractional part can never be negative. Agreed? Any change in your answers? Any of the two, domain, range, both remain the same, no change. Okay. Domain is null, range also is null. Domain, all real numbers, range, one, only one element, singleton 1. Now minus 1 cannot be an element of range, 0 also cannot be an element because this becomes positive quantity for every value of x. Signum of sine of 1 plus mod x. 1 plus mod sine x. Signum sine 1 plus mod sine x. Is this a very well defined? Is this a very well defined? What about applying sine? What about finding signum? Okay, everything is smoothly going. Domain is the set of all real numbers. Range. Can this be equal to 0? To have this equal to 0, this must be some integral multiple of pi. Can this be an integral multiple of pi? Okay, let me start from this side. This is a number between minus 1, 1. Modulus is a number between 0 and 1, both endpoints included. Plus 1 is a number between 1 and 2, both endpoints included. You are applying sine to numbers between 1 and 2. By 1 and 2, I mean 1 radian and 2 radians. So, for angles between 1 radian and 2 radian, including the endpoints, you are applying sine. What kind of numbers can be obtained as sine ratio of such angles? This is 1 radian. This is 120 degrees approximately, is 2 radians. Your arguments for the inner sine function are these. For these angles, you are applying sine. Can sine be equal to 0 now? No. Will sine be always a positive number? Can it be negative also sometimes? No. Because the portions considered are, because the interval considered is composed of portions of first and second quadrants, sine ratio remains always positive. So range will have just one point, the point plus 1. Okay. Signum of integer part x square. Can we compute this at any real point given? Yes, domain is set of real numbers. What about range? 0 and 1. You can't have negative values for this. Yes, but you can have this equal to 0. You can have this equal to positive. Range is a 2-element set. The elements are 0 and 1. Fine, good. Enough about signum function. My next function will be exponential function a to the power x. Is a to the power x defined for every value of a? X let us consider later. Consider the base now. Can a be arbitrary? For any value of a, can you obtain a meaning for a to the power x? Yes. For a equal to 0. What is 0 to the power 0? You must be free to apply values for x now. That is my requirement. You have any meaning for 0 to the power 0? No. Can a be negative? Suppose a is minus 2. Will it have a meaning when x equal to half? No. So, we demand that in order that this may be meaningful for considerable set of values of x, a must be positive. Also, a must not be equal to exclude trivial possibilities. Trivial possibility, one possibility. Yes? When will this become a trivial thing? 0 I have already excluded. If a is 1, what is 1 to the power x? Okay. Let me have a non-trivial function. Let me not have a constant function. I want a meaningful example to be taken up. Let a be greater than 0 and not equal to 1. I am considering a to the power x. For example, 2 to the power x comes under this category. 1 by 2 to the power x comes under this category as half to the power x. Not 2 to the power minus x, I am saying half to the power x. So, mainly there are two varieties. One a to the power x for a greater than 1, another a to the power x for a less than 1. Suppose we try drawing graph for this function. What kind of curve we get? Suppose to begin with, assume that our a is positive. If you want, assign a particular value for a, say a equal to 2. At infinity, minus infinity, what is a to the power x? 2 to the power minus x. 2 to the power minus x. 2 to the power minus infinity. 1 by 2 power infinity. 0. At x equal to minus 1, 2 to the power minus 1, half, there is a slight increase in the function value. At x equal to 0, 2 to the power 0, further increase. At x equal to 1, 2 to the power 1, still increase, further increases. The graph you may roughly sketch as, it is a continuously increasing function. Okay, with no point of intersection with the x-axis, but this gap goes on decreasing as x moves towards minus infinity in this direction. It tends to approach the x-axis, but never touch the x-axis or cross the x-axis. Roughly you may say the curve and this line meet each other at minus infinity. In calculus, we address such lines touching the curve at infinity, minus or plus, as asymptotes. This is an asymptote for the graph of the function. More about asymptotes will be learnt by us later. Okay. Afterwards, throughout the interval of definition, it is a monotone increasing function, never decreases, never remains stationary. What is the domain? Clear from the graph. R, set of all real numbers. What is the range? Clear from the figure. 0 to infinity, 0 excluded, infinity excluded. Agreed? Okay. Next, let me consider the case a less than 1. Example, a equal to half. My function will be half to the power x. When x equal to minus infinity, function value will be half to the power minus infinity. 1 by 2 to the power minus infinity. 2 to the power infinity. Infinity. So, starts from infinity. Decreases, x increases. Suppose it reaches the point -1. At -1, half to the power -1. 2. Value has got decreased to 2. From infinity, it has come down to 2. At 0, 1, there is a further decrease. At 1, half, further fall. At 2, 1/4. At infinity, 0. Now also the gap between the x-axis and the curve goes on decreasing, but this is happening on the other side. On this side, positive side of the x-axis. Even now, the x-axis is an asymptote for the graph of the function. Graph is monotone decreasing, there the graph was monotone increasing. In both cases, x-axis is an asymptote. In both cases, domain is the set of all real numbers. In both cases, range is the set of all positive reals between 0 and infinity. Agreeable? Suppose a is a number greater than 1. For a certain value of x, you are getting 2 to the power x as y. In order to obtain the value y, this number 2 has to be raised to the power x. The power to which a number is to be raised in order to obtain this given number, we call it the logarithm of this number to the base, this base. So, if 2 to the power x is equal to y, I define log of y to the base 2 to be equal to x. These two statements mean one and the same. Initially, we gave a definition for a power x, imposing conditions on a must be greater than 0 and must not be equal to 1. Because these two statements are, I am saying they are equivalent, this also will have a meaning only when this base is a number greater than 0 and not equal to 1. In order that logarithm of a number to a certain base may be meaningful, base must be strictly greater than 0 and must not be equal to 1. In general, log of x to the base b is defined only when b is greater than 0 and b is not equal to 1. Suppose you have chosen a proper value for the base. Can log x be obtained for an arbitrary x? No. Why not? What is the difficulty? Why log x cannot be obtained for an arbitrary x? Can't you raise 2 to an arbitrary value? Is there any restriction on the x to be used here? No. Just because I say no, with a loud voice I say no, you need not accept my statement. You have to question it. Once I say no, you should ask why no. It is not no. You can have any randomly chosen real value assigned to x here. This is defined for every value of x from minus infinity to infinity. Is it not? Are you following? So, do you conclude that this is defined for every real value of x? What is log of minus 1? My intention is to confuse you. I think I have been successful to some extent now. Where should you answer why? Yes, where should you question why? I made number of statements. First I said, what is that? In order that this may be meaningful, x must be, should x be, or can x be arbitrary? With a loud voice I said no. You didn't ask. Then I tried to confuse you. See this, see the x here. it can have any value from minus infinity to infinity, is it not? Therefore, why not x be an arbitrary number? The x used here and the x used here are not identical. The x used here is here. The x used here is this number. There is no need to get confused with this x and this y. Okay? Yes. The number I am looking for here is here. It is here. What values 2 to the power x can take? 0 to infinity. So this can have only values from 0 to infinity. This can have values only between 0 and infinity. Base, in order that this may be meaningful, base must be a positive number different from 1, and this must be a strictly positive number. Should not be 0, should not be negative. Then only it will be meaningful. And how is it obtained? It is obtained such that the base to the power, I am choosing a random base there, b to the power x equal to y means log x base b is, log y base b is equal to x. These two mean one and the same. Okay? How much? Which number? Half. Okay. Three to the power what number is 9? What power of fourth root 2 is equal to root 2? 2. Root 2 power what is equal to 16? Yes, 8. Half to what power is equal to 4? Minus 2. So, value you get as logarithm of a number may be negative. Value that we obtain as logarithm of a number may be 0, may be negative, may be positive. But logarithm is defined only for positive numbers. Undefined for two reasons. Neither base is having an admissible value nor argument is having an admissible value. Not defined. Base is not having an admissible value. for every a greater than 0 not equal to 1. Number of properties are possessed by this logarithmic function. Most of the properties you must be familiar. Log of a product, sum of the logarithms, log of a quotient x by y, log x minus log y, log of a to the power n. For admissible values of a, you are not free to assign arbitrary values. A to the power n, log a to the power n, n log a, log of a base b, change of base theorem states. Assume that both are having admissible values. You may change the base to any base you find convenient. Yes. Any chosen base. Okay. This is log of 5 square, therefore is 2 log 5. This is log of 5 cube, therefore is 3 log 5. In both numerator and denominator, for both logs in numerator and denominator, base is same. Log 5 base 3, log 5 base 3 cancel. What is the graph of log x? It depends on the size of the base b. First assume b is greater than 1. If you want, let me assign a particular value for b. Let b be equal to 2. I am fixing the value of b as 2. So I am trying to draw graph for log x base 2. What is logarithm defined on this side? No. No part of the graph lies on this side of y-axis. Our function is meaningful only for x greater than 0. Okay. Suppose x is 1. Base is 2, x is 1. What is log of 1 base 2? 0. What is log of 2 base 2? 1. What is log of 4 base 2? 2. What is log of half base 2? Minus 1. What is log of 1 by 4 base 2? Minus 2. As x decreases, approaches 0, function value will be going down, will be approaching minus infinity. Roughly, the graph will be something like this. This gap goes on decreasing, and theoretically we may say the two meet each other at x equal to y equal to minus infinity. Is an asymptote for the graph of the function. Okay. From this we notice domain for the function is 0 to infinity and range is set of values attained by the function minus infinity to plus infinity. Consider next the possibility b less than 1. For sake of definiteness, I will choose b equal to half. So my function will be log x to the base half. What is log of 1 to the base half? 0. What is log of 2 to the base half? Minus 1. What is log of 4 to the base half? Minus 2. What is log half to the base half? 1. What is log 1 by 4 to the base half? 2. What is log 1 by 8 to the base half? 3. A rough sketch may be. Okay. This is a monotone increasing function. This is a monotone decreasing function. I hope you remember, while tracing the graph of y equal to b to the power x also, we noticed a similar thing. When b greater than 1, we found a increasing function. For b less than 1, we found a decreasing function. Same thing is happening now also. Okay. From the graph, we easily find, again the domain is 0 to infinity, range is minus infinity to infinity. Let me compare now the graph of this with the graph of b power x, x greater than 1, and graph of this with the graph of b power x, b less than 1. In the same figure, let me try graph of b power x also. B is greater than 1, common. This is graph of y equal to log x base b. Now I want the graph of b power x. What is b power minus infinity? 0. B is greater than 1. B is equal to minus 1. B is 2. My b is 2 for specific definiteness. For x equal to minus 1, 2 power minus 1 half. X equal to 0, 2 power 0, 1. X equal to 1, 2 power 1 equal to 2. Then 4, then 8 increases. Okay. I don't know how accurate I was in drawing the graph. We will check it now. Any relationship between the graphs? This is graph of b to the power x, b greater than 1. Anything, any relationship between the two curves you notice? Symmetric about which line? Right, there is some symmetry. This is the graph of y equal to x, line making 45 degrees with the x-axis and passing through origin. We find that the two graphs are symmetric with respect to this line. This has not been accurately drawn. Okay. There is perfect symmetry about the line. One is a reflection of the other about the line y equal to x. This is a reflection of this. This is a reflection of this. Same thing will happen here also. If I try drawing the graph for y equal to b to the power x, I find it the exact reflection of this curve about the line y equal to x. This is the line y equal to x, and reflection of this curve about this line will be reflection of this portion, then reflection of this portion. This portion I got reflected. Now I have to reflect this part. What will be that? Something like this. The two will be exact reflections of each other about the line y equal to x. This is not an accident. Whenever two functions f and g are such that one is the inverse of the other, I am yet to give a proper definition for inverse. Shortly we will be coming to that. For that we need knowledge of bijections, functions which are 1, 1 and on to. Shortly we will be discussing all those points. For a bijection, there will exist an inverse which will also be a function. When f and g are functions of functions which are inverse to each other, their graphs will be reflections of each other about the line y equal to x. In this case, the functions considered are these two, and these are inverses of each other. For this function, this is the inverse. For this function, this is the inverse. That is why we are finding the graphs symmetric about the line y equal to x. Okay. Some problems on finding domain range for functions involving exponential function and logarithmic function. First, 2 to the power sin x. Is the function everywhere defined? Yes. Domain is R. What is the range? Sin x takes values between minus 1 and 1. So, 2 to the power sin x will have values between half and 2. Because from graph we know function is monotone increasing, it is not going up and coming down at any of the subintervals of the domain. We are safe. We need consider only the endpoints. All points between those endpoints will form the range for the function. Unlike the function x square. In the case of x square, yesterday we had experienced that. When I asked you, if x lies between minus 1 and 1, where will be x square? You said it will lie between 1 and 1. You remember it? Such a thing will not happen now because our graph is not moving like this. It is continuously increasing, monotone increasing. We will be safe now. Considering the values at the end points, we will be able to decide the range. It is a number interval between 2 to the power minus 1 half and 2. In closed interval or open interval? Closed at both the end points. Agreeable? Okay. Now, is there any change in the domain? No. Range? 1 to 4. Closed interval, closed at both the end points. Agree? Yes. Will there be any change in the domain of the function? No. Range? Will have only few points. What will be those points? This is a number between 1 and 2. Therefore, integer part will be a number. We can take what values? This is number between minus 1 and 1. When you add to it, 0 to 2. For numbers between 0 and 2, the integer part can be 0, 1. Can it be 2 also? Don't you require the number to be 2 point something to have the integer part equal to 2? No, even for number equal to 2, integer part will be 2. Can this be equal to 2? Yes. So, range will be a 3 element set consisting of elements 0, 1 and 2. Okay. Domain, no change. Range, just one element. You know, for any integer n, fractional part of x plus n will be same as fractional part of x. No importance need be given to this one. Agree? So, the index is simply the fractional part sin x. Fractional part sin x can be any number between 0 and 1, including 0, excluding 1. Therefore, this function value will be a number between 2 to the power 0 and 2 to the power 1. That is 1 and 2, including 1, excluding 2. Agreed? No change in the domain. Only range you need determine. This is number between minus 1, 1. Plus 1 will give you a number between 0 and 2. Signum can have any one of the two values, 0 or 1. Range will be a 2-point set, 2 to the power 0, 2 to the power 1. That is 1 and 2. 2-point set. The set 1, 2 will be the range of the function. Okay. Domain. Set of, no, not R. Set of all points at which tan x is meaningful. Tan x is not defined at every point. It is undefined at a very odd multiple of pi by 2. So, domain will be R minus 2n plus 1 pi by 2, n belonging to Z. Good. What is the range? This can be any number from minus infinity to infinity. Therefore, this will be a number between 2 power minus infinity and 2 power infinity. 0 and infinity. Is 0 included? No. To get 0, index must be minus infinity, which is not reachable. So, interval will be open. Open interval 0, infinity will be the range of the function. Agreed? Will there be any change in the domain of the function? No. What about range? No change. For the interval minus infinity to infinity, add 1. There will be no change in the interval. Agree? Minus infinity plus 1 also is minus infinity. Infinity plus 1 also is plus infinity. Domain, all real numbers. Now no problem. Range. Fast. 1 to infinity. Good. Closed at 1 or open at 1? Closed at 1. Domain, all real numbers. Range. Let me apply method of completing squares. The function will have as index of 2, x plus half whole square plus 3 by 4. This is always greater than or equal 0. So, the index is always greater than or equal to 3 by 4. Therefore, range for the function will be set of all numbers greater than or equal to 2 to the power 3 by 4. Interval will have left end point 2 to the power 3 by 4, right end point infinity, left end point will be a point of the interval, right end point open. Agreed. Now, no change in domain. Range. Least value attained by this is minus 3 by 4. Am I right? Highest value infinity. So, least value for this 2 to the power minus 3 by 4. Highest value infinity. Interval will have left hand point 2 to the power minus 3 by 4, right hand point infinity. Closed at left hand point, open at right hand point. Domain, all real numbers. Range, set of all numbers of the form 2 to the power n, where n belongs to Z, set of integers. Okay. Domain, all real numbers. Range, Because this is a number between 0 and 1, range will be set of all numbers between 2 power 0 and 2 power 1. That is 1 and 2. 1 included, 2 excluded. Fine. Domain is now not the set of all real numbers. Cosecant square x is not always defined. Cosecant square remains undefined when sign is 0. When is sign 0? At all? 2n pi or n pi? N pi. All integral multiples of pi. So, domain will be set of all reals with removed, what removed? Set of all n pi, n belonging to z. What is range? This function for various values of x takes values, what values? 1 to infinity. Good. No negative value is taken. Cosecant may take any value less than minus 1 or greater than 1, but square will take value from 1 to infinity including 1. Therefore, range will be set of all numbers from 2 to the power 1 to 2 to the power infinity. That is 2 to infinity, 2 included, infinity excluded. Okay. Will there be any change in the domain of the function? Yes. Now the points where secant square remains undefined are not integral multiples of pi. They will be all odd multiples of pi by 2. So domain will now become R minus set of all 2n plus 1 pi by 2 n belonging to z. Okay. A range same as before. Now also the values attained by secant square x are values between 1 and infinity, 1 included. Range is set of all numbers between 2 and infinity, 2 included. Domain. Can the denominator vanish at any particular point belonging to the reals? Is there any point where the denominator is 0? No. Domain is the set of all real numbers. What about range? This lies between, okay, this fractional part lies between 0 and 1. Plus 2 lies between 0 and 3. 2 and 3. 2 included, 3 excluded. So, okay, let me treat it as half to the power something. Why should I treat it as 1 by 2 to the power something? Let me have it as half to the power something. Half to the power a number between 2 and 3. 2 included, 3 excluded. Am I right? Yes. So, range will be, what is half to the power 2? 1 by 4. What is half to the power 3? 1 by 8. Range will be interval with left hand point 1 by 8 to 1 by 4. 1 by 8 not included, 1 by 4 included. Okay. Is base having an admissible value? Yes. To have the expression meaningful, this argument of the logarithmic function must be positive, strictly positive. Log x is meaningful only for positive values of x. Sin x is positive. When is sin x positive? When the bounding line of x belongs to first or second quadrants. This happens in many intervals. What are those intervals? One interval is 0 to pi. Another is 2 pi to 3 pi. Another is 4 pi to 5 pi. So on. What is the collection? Union 2n pi to 2n plus 1 pi. Good. Are the endpoints to be included? Can sin x be 0? When sin x is 0, is logarithm meaningful? No. What is sin x at this endpoint? 0. Not to be included. Not to be included. Agree? Take union of all such intervals as n varies over set of all integers. What you get will be the domain of the function. What about the range? Can sin x take an arbitrary value? No. Sin x takes values between admissible values are between 0 and 1. In general, sin x may take a value between -1, 1, but we have excluded certain points. Among the retained point or at the retained points, this can have value between 0 and 1, excluding 0, including 1. Logarithm of such numbers, logarithm of numbers between 0 and 1. If you want to recollect the graph of graph of log for base greater than 1. In that graph, what values are attained by the graph of the function in the interval 0 to 1? What is log 0 to the base 2? Log 0 is undefined. What I mean is, when x is close to 0, a small number, a number very close to 0, what will be its logarithm? Minus infinity. Minus infinity to when the function value, when this function value is 1, logarithm will be 0. So, range becomes interval with the endpoints minus infinity 0, open at minus infinity. What about right hand point? Can this be equal to 1? Yes, can be 1. Pi by 2 is retained in our interval. Agreed? So, what are you getting? Minus infinity to 1? 0. Close it 0. Correct ಅಲ್ಲ? Cos x ಇದ್ರೆ ನಿಮ್ಮ ಆನ್ಸರ್ನಲ್ಲಿ ಏನಾದ್ರು ಚೇಂಜ್ ಉಂಟಾ? If I change this to cos x, will the domain change? No. Will the range change? Sorry, will the domain change? Yes, it will change. The quadrants to be removed are not the first and second quadrants now. They will be second and third quadrants. Cos is positive in first and fourth. The quadrants to be removed will be the second and third. But there will be no change in the range of the function. Okay. Base is half, again logarithmic function. This is the argument. Is the function defined very well? Yes, no problem. How do you know that? Except? One second. Log base half of 2x square plus x plus 1. I want to know when is this defined, when is this undefined. Only requirement to have this meaningful, this argument of the log function must be positive. Question, when is this quadratic positive? There are two ways to identify. One is method of completing squares, another is drawing the graph. Which should I apply now? Graph. Because x square coefficient is positive, it is a parabola with vertex below. X coordinate of the vertex minus b by a minus 1 by 4. Y coordinate when x equal to minus 1 by 4. 1 by 16 into 2, 1 by 8. 1 by 8 minus 1 by 4, minus 1 by 8, minus 1 by 8 plus 1, 7 by 8. Does this mean the function value is always positive? Yes. Therefore, does it mean this is always defined? Yes. Is the domain. Is it clear? Okay. There is no point where this is 0. Discriminant is not positive. Discriminant is negative. Is it not? Okay. Also, there is no point where this is negative. Expression is negative. What about the range? What values are attained by this function? Clearly from the graph we find values attained by 2x square plus x plus 1 are values greater than or equal to 7 by 8. So this takes all values greater than or equal to 7 by 8. For numbers greater than or equal to 7 by 8, what will be log to the base half? If you want, recollect the graph of log x to the base b, b less than 1. From the graph, you can actually see what is the range of the function. What is graph of log x to base half? Is it like this or like this? And this one, is this correct? Okay. Our argument of the logarithmic function, this takes values greater than or equal to 7 by 8. 7 by 8 is somewhere here. This is the point x equal to 1. Log is 0 at x equal to 1. 7 by 8 is slightly less than 1. So somewhere here, from here onwards, x can take, the argument can take any value up to infinity. Therefore, what will be the range of the function? Set of all values attained by the function to the right of this vertical. Highest value taken is this. Least value taken is minus infinity. So it will be an interval with left hand point minus infinity, right hand point this point. What is the height of this point? Log of 7 by 8 to the base half. Is the interval closed? Is this point reachable? Yes. Is this point reachable? Yes. Okay. Next. First domain. When is this meaningful? X positive. To have this meaningful, this must be positive. When is this positive? When is this 0? X is 1. When will this be positive? When x is greater than 1. For x greater than 1, this is positive and therefore this will be meaningful. Okay. Now I want this to be meaningful. If you want, let us start from this side. That may be more convenient. First, this must be meaningful. To have this meaningful, this must be meaningful. To have this meaningful, this must be greater than 0. Agree? I'll write down. Log base 3, log base 1 by 4, log base 5 of x must be greater than 0. Okay. When is this expression equal to 0? When this argument is 1. When will this expression be greater than 0? Notice that your base is 3, a number greater than 1. Oh, one second, I have committed an error. I didn't give any importance to the size of this base. The size was less than 1. When size is less than 1, to have logarithm greater than 0, this is not what should take place. Let me consider the graphs. For base less than 1, this is the graph. I am right, I suppose. And for base greater than 1, the graph is something like this. Keep this in view. I want this to be meaningful. For that, I want this to be positive. I am sorry. Yes. This must be positive. Okay, there is nothing, no mistake has been committed at this stage. This has to be positive, greater than 0. Perfect. Now to have this meaningful, this must be positive. Yes. Base in a question elli bartade? Next stage alli. Okay. To have this meaningful, no. My question is not having a meaning for this expression. My question is, I want this logarithm to be positive. I am not demanding this expression to be meaningful. I want this whole expression to be positive. I want log of a certain number to the base 3 to be positive. When base is greater than 1, do you get logarithm positive everywhere? No. You get logarithm positive only from here onwards. What is this point? 1. Only for argument greater than 1, logarithm is positive. Agree? So to have this positive, this argument must be greater than 1. Okay. Hope you are following. Okay. Now requirement is this must be greater than 1. Base is 1 by 4. Base is a number less than 1 and I want the logarithm to be greater than 1. This is the graph when base is less than 1. I want the logarithm to be greater than 1. This is y equal to 1. I want the logarithm to be greater. When do you get the logarithm greater than 1? For points in this interval. Do you see it? Points in this interval means points between 0 and this point. What is this point? This is the point where logarithm is 1. When is logarithm 1? When is this logarithm 1? When this is 1 by 4. When this quantity is 1 by 4, this logarithm will be 1. Okay, let me record the values. Inequality I will place later. This must have a relation between 1 and 4, 1 by 4. Now, at this particular point, this height is becoming 1. It is becoming 1 when that logarithm is 1 by 4. For argument greater than this point, the logarithm will be getting a value less than 1. For points to the left of the point considered, the logarithm is becoming greater than 1. So, to have logarithm greater than 1, x must lie between 0 and the point that you have obtained as the point with logarithm 1. What should I write therefore here? This must be between agree? Is 1 by 4 included? No. If you include this, you get log x base 5 equal to 0. Log x base 5 equals 0 means this is undefined. Okay. Now my requirement is reduced to this condition. You want log x base 5 to be greater than 0. Base is greater than 1. You want the logarithm to be greater than 0. When base is greater than 1, when do you get the logarithm positive? When the argument is greater than 1 or less than 1? Greater than 1. So, argument must be greater than 1. Also, I want log to be less than 1 by 4. The graph to be considered is this. I want log to be less than number 1 by 4. Where is it? Somewhere here. I want the logarithm value to be less than that. Should I consider points to the right or points to the left? Points to the left. Points to the left means this. At which point are you getting log x base 5 equal to 1 by 4? Points to the left of that point where logarithm is 1 by 4. Which is the point having logarithm 1 by 4? For what value of x, this will be 1 by 4. Log of what number to the base 5 is 1 by 4. Exact value, not greater than, less than. Exact value, that number will be placed here. 5 to the power 1 by 4. Can x be equal to that? If x is equal to this, this will be exactly 1 by 4, not less than 1 by 4, will be equal to 1 by 4. So, inequality is strict. The set becomes what? Domain or range? What is that we have obtained? Range or domain? What is that we have obtained? We have forgotten. Domain. Domain. The set of all points at which the expression has a meaning. To have a meaning, this must be positive. This must satisfy this inequality. This must satisfy this inequality. X must satisfy this inequality. Then the formula makes sense. Formula will have a meaning. The function will be defined. The function will have this as the domain. What about range? Your x is between these two limits. So, this will be between, for x between 1 and 5 to the power 1 by 4, this is between 0 and 1 by 4. This is between 0 and 1 by 4. Where will be this? What is log 0 base 1 by 4? This is the figure to be considered. Infinity. What is log 1 by 4 base 1 by 4? 1. So, this value will be between 1 and infinity. Argument is between 1 and infinity. What about the logarithm of the number? What is log of 1 base 3? 0. What is log of infinity base 3? Infinity. So this quantity will be between 0 and infinity. Apply log to it. What is log of 0 to the base half? This graph. Infinity. What is log of infinity to the base half? This graph. Log of infinity to the base half. Minus infinity. That means this will lie between. We have found an example where range is considerably larger than domain. We have obtained domain as a finite interval and range as an infinite interval. Okay. Do we have any more example? Yes, one example remaining. Can be finished, I think. You have the patience. Are you following? Or have you got completely sleepy? I don't know whether it is the condition ideal to continue or should we take a break? ಮಾಡಿಬಿಡ್ಬೋದಲ್ಲ ಓಕೆ ಹೇಗೂ ಮತ್ತೆ ಪುನಃ ಅವರನ್ನು ಮಾಡಿಸ್ತೀರಲ್ಲ ಅವ್ರಿಗೆ. With this we will be finishing problems on domain range. Next we will have to pass on to the next topic. Next topic will be considering variety of properties of functions like one-oneness, onto-ness, bijectionness, definition for inverse, definition for composite of a function, when will a function be periodic, when will a function be what else, even, when will a function be odd, so on, and examples, some examples. I want the function to be meaningful. Set of all x such that log base 2 minus x of x minus 3 is defined. When is logarithm defined? Two conditions. One, base must be greater than 0, not equal to 1. Argument must be greater than 0. Once these conditions are satisfied, will the expression have a meaning? Yes. These are the only conditions to be satisfied in order that the expression may have a meaning. Okay. So you need solve only these inequalities. This means x is greater than 2 or less than 2? Less than 2. This means greater than 3. And this means x is not equal to 1. What is the set? What is the set? What numbers lie between are greater than 3 and less than 2? Is it clear or not clear? Problem turned out to be, it looked like a very complicated problem, turned out to be a trivial problem. Let me consider some changes now. Okay. What happens to this part? Remains x less than 2. No problem. Do you have any point belonging to the domain now? Yes. What are the points? Does this already exclude 1? Yes. Is the domain for the function. What is the range? What values are taken by this function? To determine the set of values taken by the function, first I must be specific about this base. It depends on what value is attained by the base. If base is greater than 1, certain values will be attained by the function. If base is less than 1, something else is going to happen with the value of the function. My x is between 1 and 2. Therefore, 2 minus x will be between 0 and 1. This base is certainly a number less than 1, greater than 0, less than 1. What is the set of possible values for the function? X is between 1 and 2. X minus 1 is between 0 and 1. You are applying logarithm for a number between 0 and 1. The base is less than 1. What values the function can attain? Refer to the graph. It may be simple. Graph is here itself. Okay. This is 1. Your x is between what values? 0 and 1. Base is less than 1, taken care of while drawing the graph itself. What values the logarithm can take? What values are attained by the graph? 0 to infinity. 0 to? Okay. With which point is included? With whether 0 to be included or not to be included? Not to be included. Over. Always, while determining the range, this will be an ideal approach. Having the graph drawn and referring to the graph, you can actually visualize the range of the function. It will be extremely simple to determine the range. Okay, both domain and range have been successfully obtained even for this revised function. Enough, I think. We have enough exercise or practice over determining domain and range for a function. More examples will be given to you later at your practice sessions. So, in the next session, we will be shifting ourselves to the next part of the chapter. That will be discussion about different kinds of functions like periodic, then even odd, then bijection, so on.